Okay, we are going to find dy dx and also d2y dx2 for these parametric equations right here. And of course, let me write this down for you guys. Here we go. For dy dx, what we need is, of course, dy dt and then divided by dx dt. Okay. For the dy dt, of course, just look at this and ask yourself, what's the derivative of tangent t? And the answer to that is secant square t, all right? And then we are going to divide this by dx dt. We look at this and differentiate secant t. We get secant tangent, and the inputs are both equal to t. So secant t times tangent t, like this, right? And of course, just keep your t. This is the input t, this is the t from tangent, all right? So don't cancel all the t if you don't mean to be. Anyway, this right here is secant square t. This is secant to the first power t. Of course, we can cancel this out with one of them, like that. So we get secant t over tangent t, right? And can we do more? I think so. So here we go. For the top, this right here, we have a secant t. And let me just write here as 1 over cosine t, right, for the top. And then we divide this by tangent t. Well, tangent t on the bottom, like this means what? Cotangent. And we can look at this as cosine t over sine t. Can we do it like that? Yeah, because tangent t on the bottom is the same as that. And when you do this, you can cancel this and that out. All in all, we get 1 over sine t, which is, of course, cosecant t. So c as c t, like this. So that's it for the dy dx. Now moving on to d2y dx2. Remember, we have to differentiate with respect to t of our first derivative. So let me just put this down here for you guys real quick. And then we are going to divide this by dx dt. So how this looks like is we have to differentiate cosecant t, and then we are going to divide it by the dx dt, which is the derivative of that, which is secant t tangent t, right? Okay, so what's the derivative of cosecant t? Well, the derivative for this is negative cosecant t cotangent t, like this. And seriously, just keep your input t, just write it down clearly and all that, all right? And then we have to divide this by secant t tangent t, like this. And now you have to remember your trick identities and all that cancellations, just like what we did over there. We have to do more. Here we go. All right, so for the red part, I will just write it down in red, of course. I will change everything in terms of sine and cosine so that we can see the things being cancelled much better. Okay, we have the negative right here. That's good. For the cosecant t, this is the same as 1 over sine t. Good. And then for the cotangent t, this right here is what? Cosine t over sine t. Right? So that's also good. Then this secant on the bottom, right? This is secant on the bottom. It's the same as cosine t. 1 over secant is the same as cosine, right? And then 1 over tangent is again the same as what we talked about earlier, which is cosine t over sine t. So this and that is for this. And now how are we going to simplify this? Well, this right here can be paired up with that. That will give us a cotangent. So let me just write this down. We have a negative. This and that together is the first cotangent x. And then we have another one. This right here is another cotangent x. And of course, this is the third one. So we multiply cotangent x 3 times. And finally, I will just write this down right here for you guys. Of course, this is negative cotangent to the third power. What did I put on x? I mean t, my bad. So this is the problem with parametric equations sometimes. So this right here should be t, and also t. And of course, this right here is just as t as that t anyway. Cotangent t, cotangent t. And of course, it's negative. And let me just change to the right color. We're done. Negative cotangent to the third power t, just like this.